Okay, I'm going to make a video now on solving polynomial equations. Much of this we know, but we're going to go into some grade 12 level equations where it's beyond a quadratic and solve those. Okay, so right now we're looking at solving polynomial equations. Okay. So first we're going to look at an example here where we've got, say, 2x minus 3 equals 7. All right, so if we want to solve this, then we can do it a couple ways. One way is the way you do this in grade 9 and 10 is add 3 to both sides. Okay, so we'll call this method 1. Okay, so we're going to add 3 to both sides. So take 2x minus 3 equals 7 plus 3 plus 3. And we get 2x equals 10. And then you divide both sides by 2. And you get x equal to 5. Fairly straightforward stuff. So that's how you'd solve that equation. Or method 2, which you may not have thought of before, is bringing everything over to the left side. So 2x minus 3 equals 7. I'm going to subtract 7 from both sides. And then we get 2x minus 10 equals 0. And this is the method that we're going to have to use for polynomials that are not linear. So for quadratics we have to do this, for cubics and so on. So at this point we're going to factor this. So I'm going to factor a 2 out. I'm going to get 2 times x minus 5 equals 0. Now when is this true? When does 2 times x minus 5 equal 0? Well, it's when one of 2 equals 0 or x minus 5 equals 0. 2 will never equal 0. But x minus 5 equals 0 implies x equals 5. Okay, same solution as here, so we're looking at it in factored form. Now, if we look at the second example here where it's a quadratic, so we've done this before as well in grade 10 and 11, so x squared minus x minus 6 equals 0. So if you want to solve this, we need to factor it. So two numbers that multiply to negative 6 and add to negative 1. So multiply negative 6 and add to negative 1. Well, those numbers are going to be negative 3 and positive 2. So we'd factor this to x minus 3 times x plus 2 equals 0. And for the same reason as we had up here, we know that in order for this to be true, either x equals 3, that makes this 0, or x equals negative 2, that makes this 0. So the solution is x equals 3 or negative 2. Okay. And that's for a nice quadratic that factors. Otherwise, we might have a quadratic like x squared minus 3x minus 6 equals 0. And for this one, it doesn't factor. There are no two nice numbers that multiply to negative 6 and add to negative 3. Okay, so when you look at the factors of negative 6, it's 1, 2, 3, and 6. Yeah, those combinations aren't going to get you negative 3. Okay, so you have to use the quadratic formula. Okay, quadratic formula, which means x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so we're going to look at this quadratic. X equals negative b, so it's going to be 3 plus or minus square root of b squared. So negative 3 squared is 9 minus 4 times 1 times negative 6 all over 2. And when you simplify that, you're going to get 3 plus or minus the square root of 33 all over 2. Okay, so you get two answers there. 3 plus root 33 over 2 and 3 minus root 33 over 2. This could be written in factored form, but there's no need to if we're just solving it. Okay, so that's quadratics. Next we'd have a cubic or beyond. So in this example, we'd have, say, something like x cubed plus 4x squared plus x minus 6 equals 0. And if we want to solve this, well, we have to use the factor theorem. So we have to look at factors of -6 that make this polynomial equal to 0. And so we've done this in the previous unit. So we find if this is p of x, then you'll find that p of so p of 1 would equal 0. Okay, you can check this out. 1 cubed, so it's going to be 1 plus 4 is 5, plus 1 is 6, minus 6 is 0. P of 1 is 0, which implies that x minus 1 is a factor. Okay, so you got x minus 1 as a factor. So then we're going to divide p of x divided by x minus 1. Okay. When you do that, so let's do synthetic here. We do minus 1, 1, 4, 1, negative 6, bring the 1 down. Negative 1, 4 minus negative 1 is 5. Negative 5. Okay. 1 minus negative 5 is 6. Negative 6 and 0. And we get now that p of x equals x minus 1 times x squared plus 5x plus 6. And we're solving that equal to 0. Now we can factor this quadratic. If that didn't factor, you could use the quadratic formula. X minus 1 times x plus 2, x plus 3 equals 0. And from this now we can state the solutions. X equals 1, negative 2, and negative 3. And it'd be the same thing for quartics or quintics or whatever, or different types of cubics. You need to factor them first so that you can solve them. The linear you don't have to factor, but for anything beyond that, you do need to factor it.